Next, we will discuss acid rain and basic oceans. So carbon dioxide in the atmosphere combines with water to create slightly acidic rainwater. This is the normal thing that happens. It's a weak acid, and the resulting pH is about 5 to 7. But when we add sulfur dioxide to the atmosphere, it can also combine with oxygen to make sulfur trioxide, and the sulfur trioxide combines with water to give you sulfuric acid. Sulfuric acid is a much stronger acid. It dissociates completely. It's on our list of strong acids, and so it will decrease the pH even further. And that can destroy structures, poison lakes, kill trees. We'll go over some of the effects here. So between the carbon dioxide that's given off from plants that isn't naturally in our atmosphere and the SO2 that's also given off into the atmosphere, we can actually change the pH of the water coming out of our clouds. This is mostly a bad thing. There's a lot of harm to it. The upside to it, though, is that if those gases were to stay in the air, it would make it very hard for us to breathe. So if they're going to be there, having them be taken out by rainwater is more useful than having them be there and not be able to breathe. So we have gases and smoke from burning coal that mix with the moisture in the air. You get nitric and sulfuric acids. They fall to the earth as rain or snow. And as that changes the pH in a lake or river, it can actually kill fish or other living organisms there. And your forest and crops can also be damaged by the highly acidic rain coming down. So for example, in a Chilean forest, the amount of water coming down gives you the elements that are equal to those arriving. So you have these calcium, potassium, magnesium that are essential for your plants to survive, and that come down, go into the soil, and are then taken by the trees out of the soil. If you have acidic rain coming down, those ones in the soil can often be displaced by hydrogen in their compounds. And so then when the tree tries to find those same things, they find that they're very scant because a lot of them have been chemically replaced with hydrogen ions. So I can take 2 hydrogen ions, and that's equal to 1 calcium or 2 potassium. They can actually displace the minerals that are found in the dirt or in the rocks near those trees. And those trees, without being able to get the proper cations to do their functions, have their leaves turn yellow, and the nutrients become really scarce in the soil, and they don't thrive like they normally would, and the forest goes into decline as the nutrients leave the soil. Here's an ion concentration as pH made from laboratories in 1999. And you'll notice that we in Oregon are actually doing okay. We've got a pH that's in a healthy area for what you'd expect. And part of that is that the industrial age didn't hit us as early or as strongly as it did the East Coast. The East Coast has more issues with acidic rain because they had so much industry there early on that was pouring these waste products into the atmosphere before we knew that we needed to have filters there to remove them again. And so we've got some pH problems going on there that are not favorable. We also have basic oceans. And these basic oceans should have a pH of about 8.2. When you have carbon dioxide, which is the waste product of living things, it enters the ocean and it becomes carbonic acid. And then it reacts with calcium carbonate to become calcium bicarbonate on the ocean floor. The advantage of this is it's absorbing our excess CO2 from the atmosphere, which is great. And the calcium carbonate regulates the pH. It kind of creates a buffer system in the ocean to keep the pH nice and stable there for the animals and plant life that are there. The disadvantage is that this pH is slowly changing. As our calcium carbonate is removed out of the water of the oceans, it becomes the amount of it becomes unsaturated, and so we start losing our calcium bicarbonate as well. And they use those compounds to build things like seashells and coral, things like that. And so you lose the shells from tiny plankton to your giant clams. Any of those are at risk for losing their shell. And the coral reefs start to fall apart. And there's a lot of animals that rely on the coral of the coral reefs to survive.